I hate about the way that we think about LabView often is we think because it's graphical, it's easy. All right? That's like saying that Japanese is easy because 150 million Japanese people speak it. Right? Seems easy to them. We use English. You know, there's a billion Chinese that use Chinese. But if I say, you know, Ohayo gozaimasu, right? I mean, it doesn't mean anything to you. I just said hello to the class, by the way. Right? So, LabView is a fully functional programming language that's aimed at scientists and engineers, right? It's equivalent to C, it's equivalent to Python or .NET or NetBeans or whatever, and it's equally complex to all of that. Having said that, for my educational psychology people, there are different intelligence areas in the brain. One of them is, if you believe Howard Gardner, who did a bunch of studies in the late 70s at Harvard, looking at people with brain disability, right? People who can't use language can solve problems. People who cannot do math because they've had a lesion on the brain that affects part of the logistical, logical, mathematical section of the brain, they can still solve problems. How do they do it? There are other organs in the brain that help you solve problems, including kinesthetic parts and spatial parts of the brain that allow you to do high-level thinking, but without using words or numbers. We're going to show you today, in 2 hours, the beginning of how to use a graphical programming language to work on a robot. The great thing that I've learned from 15 years of working with people who I bring onto the National Institutes platform and the graphical programming language of LabView is that this programming language maps onto certain problem sets better than text does. All right? I sometimes think that LabView is complicated to explain, and then I try to watch somebody explain a C program to somebody else. And they're going up and down and backwards and forwards. And I give you one last little hint to my adults, and then we'll do fun stuff. At University of Wisconsin, they teach text-based programming in their first-year program, and they were given the option of using LabView. And they decided not to, right? And so I'm like, okay, I'm talking to this person, and I said, well, but what do the students really have difficulty with? And she just says, well, one thing they have difficulty with is when these text programs get really big, they get lost in them. So here's what I do. I have them draw a block diagram of what they're doing on a piece of paper and set it next to the keyboard so they don't get lost in it. That is already in the LabView environment. So the block diagram approach to making programs happen is already here. And as you change your program, the block diagram changes automatically for you. So there are lots of ways that differently, and one last thing about engineering students. If anybody's tracking on engineering, you're probably not going to be a poet, right? And I asked this in all my first year engineering. Did you come to engineering school to be a poet? Turns out that's the part of your brain that needs to be strong for you to be a really good C programmer. All right? That's the part that lights up when they put people in fMRIs, right? Well, we give you a spatial, flow-based environment that's about physics, and it turns out you have a much stronger sense for physics than you even realize. And we put a physics analogy behind the programming language, and that's what organizes the program, and that's what makes it work so well for robots. But, having said that, it's equally complex to every other language when it comes down to it. And I can't teach you to speak this language in 2 hours or 4 hours. Plus teach you about the hardware, plus, right, get everybody to enjoy themselves. Because all the kids are bored right now, because I'm talking psychosocial stuff, right? Okay, so with that as an expectation, we're going to get these 4 or 5 robots running the best we can. Okay, you're going to get, out of the first 2 hours, you're going to get a sense for the hardware, how it hooks up, because the software part of this lives on the hardware. If you don't get the hardware set up right, and it's not talking right, then nothing works. It doesn't matter how much LabView programming I teach you, it's not going to work. You're going to get frustrated and you're going to go somewhere else. Okay? So, we're going to get these things up and running, and we will start to talk about how the graphical environment looks. All right? Is that acceptable, anybody? There's going to be an advanced class in the afternoon. The advanced class is not advanced. It's basic, going to be basic LabView programming, but based on the fact that you understand how the hardware works. Okay? Any questions before we get started? How many of you have never opened LabView in your life? Great. How many of you have programmed LabView for more than 2 years? Great. Okay, so this is going to be a little slow for you. How many of you, is this your first year in FIRST? How many teams is this their first year in FIRST? The team's first year. Okay, so we got some first year. How many teams have been in FIRST for more than 3 years? Okay, so you can see that I've got different levels of people that I'm going to have to be talking to. So if this seems a little slow from the first side, it's going to get faster. If this seems a little fast on the LabView side, well, I got to get to the good part for some other people, right? Okay? But everybody's in the right spot, and we will get everybody up and running at the beginning. I'd also like to thank Kettering for putting this on, because the more you get this done now, the more likely you'll be successful when the season starts. So thank you, Mark, for putting this on. Do you want to say anything?
Yes, I'd like to welcome everybody. If you haven't been to the FIRST Center, you're welcome to see it after we're done. There's going to be a half an hour break if you're going to the advanced one or the somewhat advanced one. And I'll be glad to show you to you. There is a break room right down here where you can eat lunch. Someone made some coffee, I think, and for the coffee people. And the restrooms are just on the other side of that wall, actually. Okay. Anyone have any questions?
Where do we go in case there's a tornado or a fire?
Okay, tornado,
out,
fire.
Out, and out.
Yep.
Right? That's my old GM training, right? You always had to know where the bathroom was, where you go in case of a tornado or a fire.
The bathroom area is actually a good place.
It's actually one of my favorite things about starting at GM. They did the first day in 1993, I was in there, they did a "Don't do this at the office" video that was 30 minutes long. And what I learned was, don't put sharp things in the really thin drawer under your desk, and don't stand in a rolly chair to fix a light. And I have since hurt myself doing both of those things, so they were right. Okay? Great. So, to start off the hardware-software interface discussion, how to get these robots up and running the first time, you can make a robot chassis, and I suggest you do this with your team at the beginning for my first year teams, right? Or my early teams. You can make a 2-motor chassis, right? With all the electric parts, make the chassis, put the wheels on it, and hook up, put a board on it that's got all your electrical components right at the beginning. If you do that, you will have a working robot with no programming necessary. So I don't have to teach you any LabView, technical LabView programming, to get a 2-motor, 4-wheel robot to run around. Does that make sense to everybody? So you don't have to know anything to get that far, all right, about LabView. You do have to know about the system and how to make it work. The most important thing that you need to know is your team number. What's the team number of that robot? Do we know?
This one is, I think it's 448.
448. Is that right?
Yep, 448.
Okay, 448. Great. So the first thing you have to know is your team number, and that becomes important. We like to think that this robot is a thing in and of itself, right? We put code down on it and it goes and does its stuff. But that is the wrong way to think about a robot. This robot is actually a really complicated system, all right? The system parts are the robot, right? If everybody looks over at these robots, they've got a brain on it. That brain right here, this Robo-Rio, it has a place that you're going to put code, right? So we're going to put code down there. That code is going to talk to my computer, right? Where do your joysticks hook up when you run a match, right? You've got your laptop or a little PC mate. By the way, the little are those still around, the classmates?
Not much. A little bit.
What is it now?
Now they don't provide anything. It's just a random laptop. So you can get the clamshell still. They offer it through first choice generally at the beginning of this, before the season starts. But
those little clamshell things, they look like computers. They're not computers. If you try to program LabView on it, you will hate your life. Okay? So I don't care what resources your district has. You have to get a regular laptop. And you should get a laptop that will come with you to the event. right? So program on the laptop, that's your development machine, but it can also be your driver station, right? So the driver station is actually part of the robot. This robot cannot run unless it is talking to the driver station. Does that make sense to everybody? All right? So even though we like to think of this as having a hardware brain and we can put stuff down in there that's going to work, until you get the driver station to talk to this robot appropriately, it's not going to do anything. Even if you put an autonomous code down there, you still have to enable it from the driver station. Okay, so I got my team number, and that's really important. So I've installed LabView. Do you guys know where to get LabView on your own? ni.com/FRC has a couple downloads where you can download the 2015 version of the event. You'll of course be using the 2016 version, so just realize that when the season starts, you can download from that site. Anybody can. You'll also get LabView in your kit as one of the options. You'll have a serial number in there. Activate immediately and write the serial number on 3 things: your development machine, your robot, and keep it in the original kit of parts. All right? Every development machine should have a copy of that activation. And I just tell you this, it's like the don't do this at the office video, because I've watched 3,000 teams. And a third of my troubleshooting is, we never activated LabView, and it won't download. You have to have a working version of LabView to download code and change it. Okay. Now, having said that, once I know my team number, and I've installed all of the software appropriately, I get a thing called the FRC driver station. See this? The driver station, the way I found it is I just put driver into my search, and it came up with the FRC driver station eventually. It's considering searching, so we can see that we're going to have a lot of fun with our technology today. Terrific. While it's searching for that, I found it, and here's my driver station. Notice that I've got a setup section. Looks just like your iPad, right? It's got the little setup doohickey icon there, and I type in my team number. That is step 1. What this should do on any reasonable laptop, oh my gosh, it worked right away. I was expecting to have to do a whole bunch more troubleshooting, which is really good for you. Do you see what I saw that is really good? See those green lights over there? It says communications, robot code, and joystick. Those are your 3 most important lights on the driver station. What that means is, I have now set the IP address of my RoboRio correctly. Does everybody know IP addresses? 10.24.24.2. That's an IP address. 299, 269, 158, whatever. That's called V4, because there are 4 groups of 3 numbers, right? By the way, this robot is a really complicated network that's sitting around, or that you're moving around, so you got to understand a little bit about networking, or it doesn't matter how much LabView I teach you, okay? So, what I just did by setting this team number is that computer now has the IP address. Oh, this is going to be fun.
What do you need?
That one. I keep this will happen often because I'm an excitable moving teacher. So I've now got my development computer over here. Development computer, which is a laptop, and it's got software on it. The software is LabView, FRC. So there are 2 things in that. There's the LabView and the FRC part. We're not using it yet, but it's on there. We've got a driver station, DS. We've got a, what's the other part of that thing called, the top part?
Dashboard.
Dashboard, thank you. Sorry, I haven't taught this in 3 months. So as you can imagine, this is not my day job. The dashboard, which we'll talk about later. We've got the driver station, we've got the dashboard, and we've got an image for the robot. What is an image? An image is a piece of software that will make the robot have the right basis for accepting code. So I've got, because I downloaded the software, I've got those pieces of software over here. This is talking Ethernet. You know, ether was the stuff that they thought was in the universe that made light be able to flow through stuff, because, like water, For a wave to flow, it's got to have a medium. So they call it the Ethernet for all sorts of fun reasons. I'm not going to talk more about that. Okay, so over here you got your robot chassis. And on the robot, you've got your Rio, your Robo Rio. If anybody calls it an RIO or a RIO or no, Robo Rio. I work for the company that makes it. RIO means reconfigurable input-output. We've got input coming from sensors into this. So we've got ins and we've got outs. And I'm going to make my outs go this way. The outs that we're going to care about right now are the outs that go to the motors. So you might have a motor over here and a motor over here. You can never get a pen to work when you're a teacher. This is the way it is. Let's get that out of the way so I don't trip on it. So I've got motors that are from my outs, and those are attached to wheels which attach to the ground. So that's the physical layer that's happening. A layer above that, or 2 layers above that, 4 and 5, is IP addresses. So I got to be able to tell. This Ethernet could go anywhere. In fact, I disconnected from the Kettering Ethernet, which is connected to all the other computers in the world. I got to have an address that tells me where I am, so that I can get a message to another address. All right. So what I just did by setting that number 448 is this is now 10.4.1.2.5. Okay? These numbers are like your address. So 10.4.48, that becomes the first part of your address. Now, give me another team number. 1506, Ketterings, Metal Muscle. They're going to be 10.15.6.5 on their machine. What that means is that their messages can't get sent to your robot because your robot's going to have your team number associated with it. This is what's underneath. If something happens in communication, you're going to have to get down into this layer and change IP addresses. You might have to, and that's why I tell you about it now. Technically, all you have to do is hit that 4.48, and boom, it updates your laptop. If your laptop is one that goes home with the kids, right, and they want to then surf the internet does not know about 10.15.6.5, and they're going to have to be able to switch the IP address back. Do you want me to show you how to do that? Just so you get a sense for it. If you ever need to switch your IP address back out of La La Land, out of Robo Rio Land, you do it under Control Panel, Networks and Settings, which is, where do they put that now? I remember doing this in XP, and this is clearly not XP.
It's probably under Internet Options.
Internet op. Yeah, sure.
If you're looking for the LAN connection.
Yeah.
Yeah. So you go under Connections.
So Internet Properties, Connections,
And then LAN Settings in the bottom right.
and then LAN Settings. Is that really it?
No, that's not it. That's the proxy, sorry.
Sorry, just a second. There should be a networks. Wait, I'll do it from over here. See this over here?
That's even easier.
Right-click, Open Network and Sharing Center. Has everybody done this before? So what did I do there? I came down to the place where my internet's usually connected, which has an exclamation point on it now, and I opened up my control panel, and I can change my adapter settings. This is my only Ethernet port. I right-click on it, I go to Properties, and now, which are we using? We're doing TCP/IP. Which version? 4 or 6? Does anybody remember? 4, right? Because we got those 4 sets of numbers. If I go to Properties here, if my item has had its IP address changed appropriately, then it would look like this, 4.48.5, and I would just have to switch back to obtaining this automatically. So, if your system stops working after you set your team number on the driver station, that's what happened. Now, I think in the current version, it's supposed to work without having a hard IP address set. So you shouldn't ever have to do that. But if you ever did, that's how you get in there to switch it all back. And you use the DHCP server. Just flick it right back. Great. So, that tells me about this address. But remember, I'm sending information across to another entity here that's got software on it. So if I make this Rio just a little bigger, that's fine, I'll just do it with pink, like that. This Rio has software on it, and that software is going to be an image. And the image makes this Rio ready to accept code. What's an image? An image is just, you know, it's like my operating system here. It comes up and it's got certain things on the desktop and it's got certain programs installed. That's an image, right? We're going to do the same thing here on the Rio. Mine was already set up, so that's good. Over here, you're also going to have LabView code that you got to get down there, okay? So there's going to be two things down here on the Rio, and if they're both not here, robot doesn't work. I know that my image is good because I see that communications works. That means the image that's down on the Rio, great. Okay? I know that that robot has code on it, LabView code, because that robot code light came on, and I know that my joystick is plugged in appropriately because the joystick light is on. If you don't see those three lights, something isn't working, you got to dig in. Okay? The last thing that I want to say about this, is what if the communication light was red? There are several things that could be happening, but the most important thing that I have to figure out is if the image is correct down on the C-Rio. If the image is correct down on the C-Rio, then I should get a communications light, and you do that with a thing called the Robo-Rio imaging tool. That is down under the National Instruments folder, Robo-Rio tool, project, LabView 2014, National Instruments program files. Again, this is not LabView, this is a utility that makes sure that your system's up and running, or running appropriately. When I double click on this tool, if I've got my Ethernet port connected correctly, I will get a piece of software that I may have already opened right here that looks like that. This is your imaging tool. What did I do over here? I've got a target. That target has a team number. Team number right there. 448. 448. So this is my development machine. This is my robot. I can also call it the target, because it's the target where I'm going to send my LabView code down to. It's the target where I'm going to send an image to make sure that it runs. Does that make sense, everybody? Great. So if you open this up and you see Robo-Rio over here and it doesn't have a team number over there, you got to put a team number on it. And what that's going to do is that's going to give essentially 10.4.48.1, I think is that one. Okay? It's either 1 or 2. It's actually 2. Yeah. Now, in the most recent version, they also are giving a name to this thing, so there's a naming server. That's what DHCP means, so you don't have to have these hard-coded addresses. So if you don't see that address on your machine, it's actually underneath, but it's attached to a name. Okay? And that keeps us from having to worry about getting around or whatever. But the big idea is that I put my team number in there, and if I wanted to make the target like it was new again, what I would do is format the target. See that button over there? Formatting it takes the image that's right here. Notice this thing says image V23. If I hit the format target and then the reformat button, it will push an appropriate image down there. Okay? And that should then make the communications light come on at the right time after a reboot. Does that make some amount of sense? Okay? So once your image is down there, then we have to come in to LabView. when you open up LabView 2014, if you have installed the FRC toolkit, so LabView is used by lots of scientists and engineers. LabView is just a base piece of programming language. If you don't put the FRC toolkit on top of it, it just behaves like regular LabView. This, by the way, is a quarter of my troubleshooting calls. And don't call me, by the way. This is not my day job. There will be there's a line for help at NI. I can't do tech support for you guys. Can't do it. This is my charity to you. I can't do more than this. If you haven't put your LabView FRC toolkit on this, you will not get this screen that says FRC 2015. So even though you open LabView 2014, the FRC version is for 2015 because LabView comes out in August and FRC season starts in January, so they always build it off of the previous version. So your 2015 is going to be on LabView 2014. So you're opening LabView 2014, you're seeing this come up. If you don't see this come up and you see LabView 2014, you need to go download the FRC toolkit. That's what has happened that's wrong. Okay, next. Once you recognize that the FRC toolkit is here, we're going to open up an FRC Robot Project. First robotics competition, Robot Project. And this will show you why you don't have to know any LabView. So this template, this project, is going to have a whole bunch of LabView code in it. All right? And this LabView code is already built for you. It's already built. You don't have to build it. And this program is set up to run a 2-motor robot from one joystick in arcade mode. It's set up to do that. So I happen to have a 2-motor robot, I think. Yeah, I see 2 motors.
Yep.
A 2-motor robot that is set to run. Oh, I actually have 2 motors here. I have a couple more motors. Oh no, those are just follow wheels. Great, I have 2 motors, and it's set to run. So this should be a totally functional robot. So I'm going to say Kettering training robot, and then it is 11 underbar 7 underbar 2015. It is 10:31 a.m. 10 underbar 31A. That's a lot of words to describe a program, isn't it? But guess what? That sort of naming convention can be very helpful for you because you're going to be making code revisions all the time, and you're going to be making these revisions in your code, and all of a sudden your code's not going to work. And you're going to say, well, what did you change? And of course you're going to be changing 7 things at once because your brains aren't working right yet, most of the kids. By the way, you know, I just want everybody to know that recent neurology is that the frontal part of your brain, the part that's about the future consequences of your actions, the frontal cortex, the myelin sheath that carries electricity, the signals, right, the electrochemical signals, and allows the signals to flow, doesn't really set until you're 25. And it doesn't really start setting or getting thicker so that those things can travel until you're 18. So your brains are not working right. I want you to know that. You feel like you're adults, but the reason that your parents look at you and go, how could you have done that, is because your brain is not working right and theirs is. Now, the reason that that's really helpful is it helps you to learn right now, and it helps you to go out and explore the world and learn stuff, right? Because your head is too big to come out of the birth canal if your brain is fully set. So you got to do all of this brain stuff later. So it's really helpful that you're in this state, but it doesn't help you avoid problems, right? You're just not thinking about the future consequences of your actions because literally your brain cannot do it. Okay, that's why when your adult team members say do something because I told you to, they're frustrated at your brain not working, okay? It's because their brain is working. All right, so with our working brains, adult brains will do this because we know that stuff can go wrong. And so we want to be able to go back to working versions, and if I say go back to version at 10:30 a.m., I know which one it is. Okay, great. So I'm going to build all of this code, And the only thing that I have to know, other than to have a fancy naming convention, is what? What am I about to fill in? Team number. Oops, yeah, not team number. The actual team number. 448. Whoop, I know. Fine. 448. Now, what am I going to build? I'm going to build an arcade drive robot on the RoboRio. If you want to build an arcade robot with an arm, you can do that. What does arcade mean, by the way? So back in the old days, there were these things called arcades. I'm not going to go back to the Romans who made arcade. An arcade was like an open hallway with openings at both ends. There's an arcade down in Ann Arbor called Nichols Arcade. It's beautiful. But that's not the arcade I'm talking about. There used to be these places where there were like physical games, right? Actually, they still are. They're still here, right? And you'd have a joystick. And the joystick would be up, down, left, right, right? So where's my pen? I move my pen all the time. I need to have like 7 pens set up. So arcade mode just means my joystick, I'm going to use one joystick and it's going to go up, down. This is going to be the Y direction. And this is the X direction. So you're going to get X and Y, and you're going to turn that using 2 wheels into some steering command and some forward or backward command, right? So that's what I'm building. Arcade drive. If I want to do it with an arm, I would use arcade robot with arm. If I have mecanum wheels are the ones that hold a moment in this direction but not in this direction so they can spin, I would use this. If I want to do an arcade drive robot on an old C-Rio, right, not a Creo, it's compact Rio, okay, which is the old thing, then you can hit that. So if you have older versions of hardware, you can still use this programming language. Okay, but I'm going to do the simple thing. Arcade drive robot RoboRio. Done. It's going into this project folder. I don't want to do that. I want to put it on my desktop. So one other important thing to know when you're using a programming language is if you click on something and nothing happens, like this, take a deep cleansing breath. Because what they found is that there's a thing called email apnea, because they first found it when people were doing email. When adults do email, it's usually stressful, because you're like answering bills or talking to your mother-in-law or whatever, right? And or your boss, God help you, right? And or your colleagues. And so usually they're asking you like for updates on stuff, and when stressful things happen to you, your tendency is to hold your breath. If you hold your breath, your blood pressure goes up. And when your blood pressure goes up over time, it expands your heart. It pushes out on the heart, and your heart stops contracting well. And then when you're old, you have heart disease. So every time that something like this happens, it's an opportunity to take a deep breath and imagine yourself on a desert island with nothing bad happening and to be happy. Now, when you're a technical salesperson and something like this happens, then what you have to do is you have to say what's about to happen. So that's what I'm going to do. So this is now going to let me, I think it'll let me put this in a new place. Is that right, Mark? I think I'm under you. Is that not true? Will it let me save somewhere else? Either way, I can go here.
You can go there, yeah. That's fine.
Okay. So what it's doing right now is saving all of this code, or not allowing me to go where I want to go. Okay. So I'm just going to hit finish. And so what's now happening, so do you have write access to that location?
I should.
He should. This happened yesterday, and
How do we get around it?
we fixed it by turning it off and on again.
Turning the whole program,
Computer off and on.
Yes.
Okay. Well, we're going to try this one more time, kids.
Okay.
Without all of the talking,
And just
which
so
is
you know-
great.
just so you know-
But it's good review, right? So
Yeah.
you get to see the whole process again. So I open LabView.
This is one way to fix LabView sometimes.
That's right. By the way, full disclosure, my mother is a computer scientist and got her degree while I was growing up in the 80s, right? So I, from the time I was 7 years old till the time I was about 14, watched otherwise normal people doing things like turning machines off and on again, hoping that it would fix whatever problem was happening. My favorite part was when they were all looking for an O that was a 0.
Oh, yeah.
Because at the time you were typing all of these letters in that related to ones and zeros rather than punch cards. She was the first group of people that didn't have to do punch cards. the compiler, when it gave an error, said you have an O that is a 0, or a 0 that is an O. Find it in this sea of A's and B's and zeros and ones. So you had to look for the 2 pixels that were the crossbar. Yeah. So that's when I decided I would never become a computer scientist. And this is another example of that. This will only happen when you're in front of lots of people. So what will happen now that I'm going to restart this machine is we're going to go through the process again without my talking, and you'll see that it actually doesn't take much time at all once you get good at it. But it's good for you to have the underlying information. So what will end up happening when I get this back up and running is it will build the program, or you will see all of the program pieces, and then what I have to do is build it and point it at the target. What does that mean? Programs are just basically sitting there on your computer until you hit a run button. Okay? Until you build them into compiled code, which can work with the chipset that's down there, the chips, that makes the ones and zeros that make the chip behave the way it's supposed to. When you build the code, you're building for a real-time operating system down on the robot. This is actually a pretty important point. Windows is a general-purpose operating system. Its job is to, and Mac OS, both of them are general-purpose operating systems. They're meant to make you feel good about yourself, right? They're meant to make you feel like you're in charge of the computer, when really they're doing all of this stuff underneath that you have no control of. In fact, early in LabView's history, when we were making it easy for people to use computers to get inputs and outputs, some really smart engineers said, hey, we should just put a PC on an assembly line, right? And so they made a program that controlled a assembly process, and there was a guy whose job it was to reboot that machine every hour. Because over that hour, the PC would stop working right, and then they'd have to reboot it, just like we're doing right now. Okay? That's a general purpose operating system. The other thing that a general purpose operating system does is when you open up like a PDF file or you open up Facebook and you start moving that screen around that's got a lot of rich content on it, the computer goes, ooh, look, you must care about that. I don't care about any other things I'm doing. So if you're controlling like a robot with that computer, at the same time you're looking at Facebook, the robot can go out of control, which can kill people. And that's, we're going to put that in the bad category, right? Bad. So your robot is actually run by a real-time operating system. What a real-time operating system does is it makes sure, it says there will be a certain amount of time that I will act on everything that you ask me to act on. And it will happen within that time, or I will tell you that an error has happened. Okay? That's what a real-time operating system does, and that's what we're going to... and it's a Windows configuration. That's great. So it's going to update for a little bit. So what's going to happen is, when you build the code, right, building the code turns it into the thing that can go down to that real-time operating system and work. So, while we're waiting for this, and we have some robots that are sort of in the area, do we have batteries for these robots?
Yeah, batteries are right here.
Let's get the batteries into the robots, and let's start hooking things up, and then if you want to come help with that and stand around and watch while people are doing it, come on over. So for the teams that are new, this is your robot setup, and you can ask about what certain parts are if you want. So come on over. Because this is going to take a while. Yeah, some more batteries. If somebody wants to use this robot, actually I'm just going to keep this one up here. Is there another robot that rolled in? So we got 1, 2, 3. Is there a fourth one? Okay, is somebody working on that one? So go ahead and get your batteries in place, and there you go. Perfect. Push that in there. And then the last thing is, let's follow the wires. So the power is going to go from the battery. And where are those wires then end? Show me where they end. They go from the batteries and they go right there. So what does that got on? Does it look like it has a switch anywhere?
So this is 397.
So let's figure out how that works. How do you think it So we got some buttons.
I'm very careful with the camera.
Okay, so that didn't do anything. All right, so what else looks like this? Exactly. So go ahead. So that closes the circuit, and look, the lights come on. So that's what's happening in that part of the code. And that powers this thing, which is your power management board, which comes over to this, which has the Ethernet cable connected to it. Where's the other end of that Ethernet cable? I'm not going to do it. I've done this before, like 3,000 times. There's no learning. Okay, great. Elite. Mark, do you want to? Mark? Yes. Do you want to log in, or can somebody log in? Yeah. Thanks.
I think you use the student account, Mark, and will that work?
Yeah, student account will work. You can run behind joystick.
Oh, okay, great. Go ahead. Keep working. Is this? Sorry, you have to read this. It looks like a dot.
It is. It's a dot and a backslash. And I don't know why.
Student must have been some elderly person with bifocals. Okay. What time is it?
Well, technically, if you're able to do something about it.
Oh, yeah.
That's it. You can. You have to
Actually, I think what they're using is DHCP. I don't think they're actually using that, but it's a good mechanism.
They're not anymore, no, because now they're using
Names like Robo.
the default, because the IP address actually doesn't change anymore. It's all like 17.22.11 now.
Yeah.
But the DHCP naming is robo-rio dash the team number dot local. So if you type that into a web address,
Roborear.teamnumber.local.
robo-rio dash the team number, lowercase r. Yes, and that will give the web interface.
Okay.
It's also it's the same web interface for firmware updating.
Okay, so when you get there, you will want to open your driver station and try to. Do we know what the numbers are for those robots?
Yeah, we're good.
So when you've got your driver station open, figure out what number you need to use by asking either of the guys in glasses who are standing. So go ahead and get that Ethernet cable over to your computer.
Anybody that wants to come over here look at this, they can.
Beautiful.
Broadcast. Yep. One of the other bots are
For this thing. Yeah, what was that? Okay, we did it that.
well, there's a problem here. Yeah.
It is. Spin it. Look, I mean.
That's one of the new things that they brought in this year with the DHCP.
Yeah.
Because you don't have to go down to the IP address level anymore. Just yes. It's also means it used to be in previous years. It used to
We could have done
like for the radio, you'd have to
to go in and manually alter the video set. You already that. So you shouldn't. I don't want to say ever, because there's always the odd chance that you still have to go in and look at some IP address stuff, but for the most part, probably don't ever need to do it in the utility.
We know there's a robot storming the castle. There's an animated video robot storming the
Do you
castle.
want us?
Yes, that's it.
No,
There's people wearing like medieval armor.
that adds an additional
Like,
level.
doing like close stuff.
It's
There's
progress.
medieval armor. There's all animated, cartoon animated.
Have you guys got? Have they got their robot talking?
They're on, you have
Yeah, we're good.
communications. You have communications.
We're all
You got green?
We're all green.
Great.
It was before.
Awesome.
No, they just started.
Okay, that's fine.
So what is that?
What's the head?
You can't do anything with this.
How are you guys doing? Who does not have their robot talking? Great. Okay, go ahead and give them the hand.
The radio hardwire. Yeah.
I'll go with the cage for one.
Okay.
Thank you.
No, if you switch this, it changes it from this one to this one.
Yeah.
So one of our kids did it during the match. We switched it over while he's driving. So it
Yes.
started controlling.
Yes.
I don't think that's actually cool. It will if you switch it over.
The only thing that I would advise is
I don't
be careful
know.
where your Ethernet cords lie relative to your wheels.
DC battery? No idea.
Oh, this one's 5.
Why?
4 is like.
And you guys should know too, when it comes to moving this thing,
I don't even know if I'm gonna be able to move it. It's so small.
oh no, you should be able to move it back and forth. Just be careful.
Okay, you see.
Oh, here, no, this is just a name, so just any information that
Make sure it's an X.
useful in terms of like that traffic, that kind of stuff, that would go there. Yeah, this one is
Last time I tried to. I mean,
Very
try it.
backwards way.
So you guys are talking? You guys are talking?
Yeah, these guys are talking, yes.
The green lights
Communications.
on your.
Two of the three, we still don't have robot.
No, oh, well, we can figure that. We can fix that. In fact, that's where we are in the process. You've got the communication light, you're good. And then we're just working on this
Right
one?
now it's disabled. Which is fine, because I actually don't know what code's on there right now. That's okay. It's probably just, I was just gonna mention that you guys, yes.
Ah,
I think it's an X.
It was like a.
Where did you plug the record in?
Just another port on there.
Oh,
But if you turn to my
we can, I think I can plug direct.
okay. Mark, I need one last thing, which is I need to activate this because it's not. Do you have the activation number?
Activation number for?
For the FRC tools. So this is not activated right now. Nope.
Okay.
And it won't let me build,
You need the LabView serial number?
which means we need to reconnect to the internet.
Hold on.
I need the serial number.
I got it. It's on a flash drive in my backpack.
This is why you write the serial number down in 3 places.
You have it on here? Bring it up. Yeah, you got it on there? Bring it up. We keep it in like 14
Yeah,
places.
great, exactly. Yes. And one of them should be at the development.
Can you hear me? It's M7.
Just a second. Can you just text it to me? No, I'm kidding. M7
9X
9er X
92
9er 2
808.
808. Okay, great. So I need this connected back to the internet.
That's a fun thing.
Yep. Okay, so everybody come back around and take a look at what I'm doing right now. So, you remember how I got here? I opened up LabView. I said make a new robot code. Where we ended last time and I had to restart, that's where I am right now. So after I hit make robot code, this project window came up. The project window is an organizational tool in LabView that organizes all of the software. So all of this software has been made for you. The most important part is the robot main. That's the main robot code. But there's also team code underneath that's got your autonomous independent code, your teleoperated code. We'll talk about that when you're older. And we have support code. So all of this code here is ready to be built appropriately to go down on that real-time operating system. But I haven't built it yet. And so what I did was I came down under Build Specifications. This is the only LabView that you need to know, actually. I'm building the FRC Robot Boot Up Deployment. Take a look at what I do. If you learn nothing else from this entire class, this is the most important thing that I'm about to say. So I need everybody's eyeballs. If you don't know what to do in LabView, right-click. Right-click on everything, early, often, all the time, like voting in Chicago. You right-click on this boot up deployment, and you get options. Now, the second most important thing after you right-click is to read with your eyeballs in a sensible direction. Don't just start guessing at what to do. Read every word that shows up. And if I do, I can see that one of my options is to build. So I need to first build this code into an appropriate format so it can be run as a startup program on the computer. So I'm going to build that. And when I build, it initializes and it comes up with this kooky error that says you have not activated your LabView. And it will do that in a second. Am I now connected to the internet?
Yes, you are.
Great. If I am connected to the internet, let's see if I can do this in a sensible way rather than doing it in a nonsensical way. I'm just going to do it in the nonsensical way. So, see this? Build was unsuccessful. Something came up. I'm reading with my eyeballs in a sensible way. The build was unsuccessful. It uses vision automation, which is currently in evaluation mode. That's how I knew that this was not activated software. It says, whoops, currently in evaluation mode. It's right on the screen. So I don't want to be in evaluation mode anymore, and I'm going to activate LabView. It says use the NI License Manager, which we're going to launch. So the NI License Manager, National Instruments, made all this software, and one of the things that's on here is Vision Acquisition Software, which looks activated. Let's see if my 2014 modules, shouldn't need that. There we go. Full Development System, modules. Oh, toolkits. There we go. Oh, and this is in evaluation mode. Okay, so this is my vision acquisition software. It turns out you can hook a camera to the RoboRio. And I right-click on this and I activate it. I should have asked you what I was supposed to do. I didn't know what to do, so I right-clicked on the thing. And it said the only option. I read the option, it said activate. I said, well, I would like to activate. Can you now hook me back to the robot?
I can.
You have to be connected to the internet to do this. This is why you want to do this early. Because if you're at the regional, can you use internet in your pits? No. So now, if you haven't activated at the regional, I got to run around and try to find you an internet connection, right? And you got to find your serial number, which you've left back at the school, right? So that's why we put the serial number on everything, which is what they did, and you're able to connect to the internet at the place you need to activate. You need to do this day one, okay? So it's a good instructional point. So now that's activated. That was the vision tools. And now I should be able to come back over here and build. Building takes a couple minutes. This is this is actually a good moment for reflection. This tool chain that I'm about to teach you is actually running the Large Hadron Collider in CERN in Switzerland. The largest machine in the world. The beam, you know what the Large Hadron Collider is? So they take these electrons, and it turns out electrons, you can control them with magnets, so they have these big magnets, and they put them in a circle, and they turn this little electron. They can take an electron, and if they turn on that magnet, it'll get sucked towards that magnet, right? And they turn this one off, so they got all these rings of magnets, and they keep turning them on one after another, and it pulls the electron all the way around the... Unsuccessful again. During the evaluation... okay, I'm going to close LabView and reopen. So when the electron is turning around in this big tube full of magnets, you can also make the magnet on the top stronger or the magnet on the bottom stronger, which can pull the electron up and down. So this thing, what they do is they spin one electron in this direction around this huge circle, and they spin another electron around in this direction, but they keep them apart from each other, so that one is going around and they miss each other. And then once they've gone fast enough, they take these two electrons and they bring the two circles, the two paths, so that they collide with each other. That control is done with the exact same thing you're learning to program this robot. Now that should be pretty cool, all right? Also, SpaceX, their launch software, LabView, right? So, you're learning things that are going to be important. I'm just going to see if I can close this again and see if it accepts the activation that I just did. But it's a good time for review anyway. So, I opened up LabView. I go to Projects. I do an FRC Robot Project. I give it an appropriate name, which I call Kettering Training 11/7/2015. Now we're at 11:01 a.m. and I give my team name 448, arcade, finish. It's going to configure the project. I'm going to come down to my build specification. I right click and I build. The reason that I brought up that time for reflection was that this takes a couple minutes. So you got to realize that this is a really complicated program because it's running the Large Hadron Collider too, the same software stack. So we've prepared this software stack so that it will run all sorts of things, not just this robot. Okay? So you got to be prepared for it to build for a couple minutes. Whenever you make a change in the program, in order for it to be down on the robot, you have to build that change by right-clicking on the build, and then you have to run that program change, that built program, as a startup. Thank you. Building successful. We like it when progress bars go all the way across the screen. Done. That was building. Building does not put the program down on the robot. You've got to run that robot as a startup. And what does that mean? There are two parts to getting the program down on that machine after it's built. The first part is it has to be deployed. It has to travel across the wire to get over to that machine. The second part is it has to be put in the non-volatile memory. What does volatile mean? Volatility is when something changes, right? Volatile memory, when you depower the robot and repower it, that memory is blank. No matter what you do, it's volatile. The non-volatile memory keeps the program, and I make this symbol because it's all the logic gates that have been closed to make that program happen. It keeps it even when the power's off. So running it as a startup, running this built software as a startup, deploys it and puts it in the non-volatile memory, so every time you repower the robot, it's there. All right? What do you have to do in order to carry the robot onto the course during, before a match? Can you carry a powered robot? That is not safe. So you must depower the robot in order to carry it onto the course and then turn the power on. If you have not gone through both of the steps of building and running as a startup, your robot will come up and you'll hook up your driver station and what light will not be on? The robot code light. If you open up the driver station and this robot code light is red, that's what you did. If your robot has come on and it's talking, communicating, and the top light is green and the robot code is red, that means somebody did not run it as a startup. Okay? So, how do we run it as a startup? You tell me. What did I do to build?
Right click.
On what? Read my options here. From the top to the bottom. Project, my computer, targets, port code, team code, robot code, dependencies. Oh, build specifications. Build specifications. We like that. This is a build specification under that. So what do I right click on? What thing, give me some words that I can click on. Is it the top thing, the bottom thing, the blue thing? What is it? The blue thing that says FRC Robot Deployment. This is your built code, or this is your code. So you right click on this, you read from top to bottom, deploy. Sounds tempting, doesn't it? What'll that do though? It'll put it down there and if you depower the robot, it'll go away. You don't want that. Build, we already did that. Unset as startup, that's just crazy talk. Run as a startup, great. So now I'm going to run this as a startup, and you're going to see that this now deploys and gets put in the deploys down to here and gets put in the non-volatile memory. So we've deployed. Oh, this is great. This is great because lots of people, they say, oh, error. What do I do? Well, what do we do when something pops up in front of you? You could right-click on it, but that would not help you in this case. But if you read it sensibly, you say, oh, we got a conflict. It says the target is already running a real-time startup application. Press OK to confirm you want to abort the existing application and connect to the target from the project. Right? That only makes sense. Something's running down there. Do you want me to kick it off or not? And put the new code there. So what do I have to do? Press OK. Exactly. I just want you guys to say it because if I say it to you and you're zoning out, then you won't remember it. If I ask you questions, you might remember it. We've got a prayer.
Yes.
What, by the way, has happened on my driver station? Which light turned red? Robot code turned red. Exactly right. Robot code turned red, which means there's no robot code down there. When I close, by the way, you can click the close on successful completion. It'll always close on its own. When I close, this thing now reboots. And that's why there's no code down there right now. It takes about 30 to 45 seconds for the RoboRio to restart and get its bearings. So you'll start to see some things blinking, and then in a couple seconds, you'll see the robot code light come on. Don't panic at this point. So, there are two things that happened in this instance that caused the communication between this development machine and this robot not to work. The first thing is that Kettering sets a proxy setting on its machines that what's happening when this talks to when the development machine talks to the RoboRio is that there's a handshake that goes on. I send it something, it sends me back something, and there's a little heartbeat down there called a watchdog that's going, right? And when those handshakes happen at the right times, everything works. The proxy setting that Kettering is putting on these machines causes that handshake to break down. It's also true that antivirus software and firewalls can do the same thing because they put this barrier between the handshake and the handshake can't happen. So that's one thing that happened. When Mark gave me his password and his administrative rights on the machine, I could turn that proxy setting off. And that's what allowed that green light to go on. The most recent problem that I've been having for the last 10 minutes is Mark's login ID in order to save files on the computer, has to be connected to a central server at Kettering, which means my Ethernet port has to be connected to the Kettering network. Well, if my Ethernet port is connected to the Kettering network, it's not connected to the robot. So when I was connecting to the robot, I couldn't save files, and the active building and the active deploying, actually not the active deploying, the active building requires you to save files, right? So I had to unconnect and reconnect several times. So I had to save files by connecting to the Kettering server, right? Make sure those files were saved and open, and then connect over to the robot. And the robot connection took a long time to connect. It takes about 4 or 5 minutes to connect, because he's looking for things that are at the central Kettering server that aren't there. Okay? So, the long and the short of this is that on your machines, for your teams, you must be an administrator. You must have open access to write to all sorts of places on the computer. And you must have the ability to go to the internet unrestricted. You have to be able to turn off your antivirus. You have to be able to turn off your firewall. If you can't do all those things, you'll end up in a situation, no matter whose software tools you're using. Because I've seen this happen with the C tools, and I've seen it happen with the NetBeans, etc. Now, having said all that, now that we've done the kabuki dance of getting this to talk, we've run the program, you can see that robot code lights up. So we've built it, we've deployed it, and you guys will be able to do this at home with much less effort, because you'll have access to your robots. And I should be able to, well, it looks like this may not be hooked up correctly to run that robot code. Oh, this is a good time to show some of the debugging tools that are available. For instance, there is a, do you want the...
Yeah, USB devices.
So I can notice that when I hit buttons on this USB device, this is USB device 0, what?
They're Victors. They're new Victors. The default is for old Talons.
Oh, I see. Okay. So we had this programmed for the wrong motors for this robot. But one of the nice things is you can see that the code is running, and you can check that your joystick is the right joystick. So down there, let me put this up higher on the screen. There is a USB tab on your driver station that allows you to check. I can hit buttons, and I can move this around, and you can see the axes working. So now I know that this joystick is working. It's just something down there that's not working, right? Remember, these robots are complicated. There's a lot of communication paths between this joystick and that motor. So lots of things can go wrong. If you build your robot piece by piece and use some of the debugging tools, you'll be able to see what parts of the system are working and which parts aren't. Now, let's do a couple other things that you should know about. One is, you can look at graphics about this robot and how it's running. For instance, this graph over here, it's showing me the CPU usage, which is the red line, the volts in the battery, which is the yellow line. It'll show me what part of the match I'm in, whether I'm in autonomous, teleop, or disabled, or test, and I can see how many packets I'm losing. Because I'm not doing very much on the robots, I'm not losing any communications packets, or you'd see blue bars over here that show the percentage of the packets lost. So this is a troubleshooting area as well that you can access. Now, the other thing that you want to know about code, oh, actually, why don't I enable it? The other thing that you should know about code is that this driver station, like I said, is actually part of your robot. The robot is both things together. And if you do not enable your robot, you might think that I plan to do that to show you that this is very important. If you enable your robot, then the robot will run. So you must build the code, run it as a startup, and then enable the code for the code to start. Some other things to know about this driver station software is you can run a practice match. Some people just turn on teleop mode, or autonomous mode and let those two modes run and then they do some testing. But if you actually want to see what your robot is going to do during a match, you can run a practice match. And the practice match, when you enable it, you'll see that you count down and you go into, you're in disabled mode for 5 seconds, and now I'm in autonomous mode. And now I'm in, after 15 seconds, I'll be in teleop mode again. And now I've disabled for a second, and now I'm in teleop. Do you see that? The green line here, disabled for 1 second, and now it's in teleop. And if I run my robot, you can see that my battery responds. As I'm exercising the motors, the battery voltage is moving around. If you see that battery voltage go below 9 volts or 8 volts, then you're going to lose power to your C-RIO. It's going to reboot. So that's one troubleshooting thing you can look at. I would try to get you guys to do this, but because you're all now logged in under Mark's login, we would have to do all of the unplugging of cables and replugging of cables to do the building and the saving and then the deploying. And I don't think we can do that. The big idea is you don't have to know any LabView to get started. You open up LabView, you build a robot, and as long as your development machine and your robot are talking to each other appropriately, you'll be able to download code very quickly. Let me do, are there any, I know that there are lots of questions about why things might not have worked. Are there any general conceptual questions about the parts of a robot and what you have to do to get robot code down onto the robot? Any general questions? Okay. Let me show you one other thing before we break for lunch, and I think this will be useful as well. We haven't looked at any LabView code yet, but LabView, you'll need to connect me back to the internet. So I'm not going to download any of this code yet, but I will show you that there are examples. So take a look at what I've done in LabView here. I've got my LabView project open. Thank you so much, by the way. I've got my LabView project open. There's a help area. See that? Help. I hit help and I can find examples. The example finder is arranged by the area of example. So what I mean by that is what types of examples have been created. You're going to want to look at or look for the FRC Robotics examples. If you take a look at your RoboRio examples, if you want to use a joystick, here are examples for that. If you want to do pneumatics, here are examples for that. Pneumatics is really complicated. Well, so I won't do that first, but, well, actually I will do it first. Fine. If I open up the pneumatics, and I want to do a solenoid with a compressor, which you can look at the manual for FRC to see how to set up a pneumatic system. By the way, pneu in Greek means air. So pneumatics is where you have air pressure and you're delivering power through air pressure rather than a motor. So when I open up my project for the solenoid with compressor, you can see that I have a RoboRio here, and it's got an IP address that's not the IP address that I would expect. So the one thing that you have to do that's not LabView again, but is based on your knowledge of the world, is you have to point your example code at the actual RoboRio that you have. Now, let me show you another thing that's important before we do that. Which, I can't actually get to it because I'm not connected to the RoboRio, but that's okay. If you open up any browser...
Nope, Internet Explorer only.
I'm sorry, if you open up Internet Explorer only, so don't try to stick it to the man on this one, right? Don't use your Chrome, don't use your Mozilla, just use the one that Microsoft has made. If you type in RoboRio -your team number .local, you'll get to a configuration page that allows you to set all of the settings on your RoboRio. So the only time that you have to use the imaging tool is when your RoboRio isn't talking at all, and you go and send a new image to it. I did that before. Did I show them that? I don't think I showed them that. I did it in the background while you were waiting. I'll show you that in a second. Once you put the right image on, you should be able to go to roborio-teamnumber.local and you'll get a configuration page. I can't show you that configuration page right now because that would force me to go over to the RoboRio again, which takes 4 minutes to do. But that name, roborio-teamnumber.local, is the name you have to tell the example program about. Now, if I want to tell this example program about RoboRio, what do? What's the number one thing you should remember from this class? Right click. You're going to pass this class. That's very good. If you right click and read appropriately, you can go to Properties all the way at the bottom, and you can give this thing a name, -448.local. And as soon as I do that, okay, then this will point at that if I could hook them up, and you'd see a green light come on. If you don't see the little green light here come on, you right-click and connect. So, I point this at the right RoboRio, I then connect to that RoboRio, and I can go in and look at the example code. So, double-click on this example code and look at what we've got. Because this is a graphical environment, this is LabView now. This is the front panel of a program that I can hit the Run button and run. It's got my wiring diagram on it. You want to know how to wire a pneumatic system? Here it is. On all of your example code in LabView, there are similar pages. So if you want to do let's say an extra motor. Say you've never used a relay before. Let's open up a relay project. So here's my relay project. I would right click on this, I would go to Properties, I would set the right name, .local. Say OK, then I would connect, watch for the green light, and then I would be able to open up my relay front panel. And if I open that up, take a look. It's got the wiring diagram. Here's how you hook up a relay. The same thing is true for motors. The same thing is true for vision. So we're giving you a lot of help here. If you run this code, which I can't do right now, if you run this code, it will only run if you hit the enable button on the driver station. So the three things you need to know to use an example are you point this example at the right RoboRio, you connect to it, you wire everything up correctly, and then you run the code and enable, and it'll run. And you'll be able to watch these pieces of example code work. The graphical nature of this, just to give you a little taste of it, looks like this. So, this is a structure, it's a loop. Everything inside the loop happens over and over and over again. By the way, it's a little picture of an arrow bent up. So this little thing right there, that's an arrowhead. So it's basically telling you that this happens over and over and over again. Everything outside of it happens once. But there are words here, so if you've got word people, great. They can use this too. So you open memory locations for the solenoid and the compressor. This says solenoid, that says compressor. You then set your solenoid and your compressor values in the loop. And then after the loop is done, you close your solenoid and compressor values. So that's how you read LabView code. It basically has functions, which are squares, that spit out data onto wires. And then these structures organize the program, and the program runs. So that's the general idea about how LabView works. In the afternoon session, we won't use hardware, and we'll just program LabView from scratch, which should be a worthwhile thing to do. So you'll get a general sense of how to use LabView. I'll come back and then show you the main code at the end of that session, and you'll be able to at least talk your way through it. Okay? Sorry that we had technical difficulty, but again, I think it's worthwhile to know that when things go wrong, you can get them to work as long as you keep a good sense of what the system is doing and what each piece of the system is doing. So thanks for coming to the first session, and if you put LabView onto your computers, we can try to get those computers to hook to these, because